the first question is, what is Kafka? In your resume, if you mention that you worked on Kafka or you have experience on Kafka, then definitely you're going to face the questions on this topic. Kafka is a powerful open source distributed platform for handling real-time data streaming. This allows you to publish and subscribe to those streams of records similar to a messaging system. It is very well known for its high throughput, fault tolerance, and ability to handle massive amounts of data. Yeah, you might be getting something out of this definition, but interviewer might not be impressed with your answer, right? So the immediate next question from the interviewer is, can you explain a bit more how actually Kafka works and how it handles large pipelines? So to answer these questions, you must have some knowledge on these topics. That is, what is messaging queue and what is the pub/sub architecture. Don't worry, we got you cover everything here. We'll take you through the simple visuals of the messaging queue and the Kafka flow or the architectures so that you will be in a position to answer all those questions. So now let's explore what is messaging queue first. So generally, queue is line of things which are waiting to be handled. If we take an analogy or an example of a toll gate, the vehicles coming are wait in a queue until the toll checker process their toll fee. Similarly, coming to the messaging queues, technically, these queues will hold the messages or events, or we can say the streams which are coming or produced from one of the service. Then those events will be stored for a certain amount of time or temporarily at the message queue, and then they will be delivered to the respective end service, or we can say the consumer service. Here there also be a communication between the messaging queue and the services. Like service 1 will ask here messaging queue, hey, have you delivered the messages so far I have submitted to you? Then message queue will answer to the service 1 once all the messages were delivered to the service 2 or the end service. And this process of producing and consuming events continue through the messaging queue or the broker asynchronously between the services. This is how the simple messaging queues or MQs will work. Now let's explore the what is pub/sub architecture over the messaging queues. So in a typical microservices architecture, we know there will be a multiple services involved. Hence there will be a number of producer and consumer services, or we can say multiple publishers or subscribers. The message broker sits in the middle of the system and helps multiple services to publish the events and messages centrally to the system, and these messages or events will be delivered to the respective subscribers or end services. And hence here the important thing is the configuration, that is mapping config between the publisher and the respective consumers. I hope now you are in a situation to answer what is messaging queue and what is pub/sub architecture. Now let's see what is the actual architecture of the Kafka and how it works. The reason I'm taking you deep into this topic because there is all relation between these messaging queues, pub/sub architecture and the Kafka flow. So you will be in a situation to answer any of the topics coming on to you. So finally coming to the Kafka, it supports publishing and subscribe to the events and streams. Unlike traditional messaging queues, it can store events as long as you want, and it can also process events when they arrive or on demand. If we take in real world services like web events, stock prices, financial transactions, emails, audits and analytics services, they generate a huge or heavy data in a seconds or minutes, right? And this data has to flow to the end services or end users asynchronously and continuously. So for this kind of heavy and data streaming systems, the traditional messaging queues or pub/sub architecture not fits. And this is where Kafka comes handy. Kafka provides dynamic storage capacity and message broker system inside it. So these data events or streams coming from the systems were placed into the different message brokers based on the topics they categorized. Since these brokers has to store and process the large amount of data, again these brokers were divided into partitions for better performance and horizontal scaling. And coming to the topics, if we take an example of stock price, this data has to continuously broadcast to the audience or the applications using it, right? So this is stock price topic, and the subsystems which are subscribed to this topic, they will continuously get the data or messages from this topic if they are subscribed to that particular topic. Now let's explore what is the typical message or data contents that is flowing to the Kafka. So the data or message going to the Kafka will contains key, value, timestamp, header, partition and offset. So when I say a message or event or record or data, these all are the same for the Kafka. Suppose if we take one example of a user order from an e-commerce system, from the service system it can post the data like cart ID, what is the value and what is the timestamp. There can be a header message from where it is originated, and finally the partition and offset ID, which are important. Partition and offset IDs were added to the message by the Kafka once the message is written to the topic. Usually, this data will be formatted in a JSON structure and will be posted to the Kafka. So when a service or application is connected and configured with Kafka, the respective systems also configured with a serialize and deserializers. Before the message was posting or reaching to the topic, the message has to be serialized and converted to the bytes. This is what the serializer does. On the other side, this is same with the deserializer. It converts back the bytes to the original message. So now you can go through the differences which makes Kafka special from the traditional messaging queues. So that is all about the Kafka. I took little time of you for this, but I hope it worked for you. Now